This unit is called Basic Integration and Application. So you're going to learn, honest to goodness, you're going to learn the basics of how to take an integral, of how to undo a derivative. Now, at first, we're going to call it an antiderivative. So we're not going to call it an integral yet. We're just going to call it an antiderivative. That is integral. Now, that comes from that for a sum, S-U-M.
Oh, like, is that the same thing as the summation thing?
Yeah.
What?
Yeah. You will see. What I want you to do is turn to a partner, or if you need to, get in a threesome. And I want, let's see, 2, 2, you 2, 2, you 2, so pairs. And what I want you to do, I want whoever's birthday is closest to today to go first. So, now what I want you to do, whoever's birthday is closer, you're going to pretend that your partner has not learned how to find a derivative yet. What you're going to do is you are going to explain to your partner how to find the derivative. And I'm going to give you a function that I want you to teach them how to find the derivative of. I want you to teach them how to find the derivative of x cubed. Explain it in words. How do you find the derivative of x cubed? Now, let's come back together. So, you guys did some teaching, and hopefully the other person did some learning. And for the person who did the learning, what do you do? Multiply the coefficient by the exponent. And then put the variable. And the exponent minus 1. So what you said was, yes, that's it. So what you said was, and you can write this down, multiply the exponent by the coefficient. And then what did you say?
Keep the variable.
Keep the variable, and what? Subtract 1 from the exponent. I didn't write down keep the variable, but you know that. Now, I want you to look at the next piece. To find the antiderivative, we're going to undo finding the derivative. Now, if we undo finding the derivative, I don't like opposite. He says opposite, but he's really not right on that. And in the reverse order. Now, I don't want you to even pay attention to that right now. Don't look at it on your notes. Don't look. I'm going to give you a function that is the derivative of some other function. No, I just want you thinking in your head. I'm going to start with an easy one. If this was the derivative, what was the function? How did you figure that out? There you go. You add 1 to the exponent, and you divide what now? You divide the coefficient by that new exponent. That's exactly what you do. Question?
So is there going to be like a reverse chain rule, reverse all this stuff?
No.
Oh.
No.
That would suck.
No.
That would suck. There is time.
Add 1.
Does that exist though?
I don't think so. Add 1 to the exponent. Let me make sure I get my words right.
I have a question.
Uh-huh.
What if it was like,
That's supposed to say coefficient.
So we're only going to do this for like
Polynomials?
polynomials?
No, but that's how we're going to start. Now, no, I'm glad you asked. The answer is no, but now I'm going to ask you another question. What's the derivative of that? Is x cubed the only function that has a derivative of 3x squared? Is that what you were thinking about? Is x cubed the only function on the planet that has a derivative of 3x squared? Give me an example. No, that doesn't have anything to do with it. No. No, but is there any other besides just x cubed that has a derivative of 3x squared? Like what? What's the derivative of that? What's the derivative of that? Oh my gosh. What's the derivative? Indeed. Indeed. Don't forget the C. Yeah. Now, so now let's look right here. The antiderivative of a function is denoted by this. If I wrote the integral, don't write anything down yet. If I write, now, don't worry about this dx right now. All that means is I'm doing this with respect to x. You remember how I could write like d dx of x cubed? And that meant I'm taking the derivative with respect to x. This means I'm taking the integral with respect to x. That's all that means. So don't sweat that. The integral of 3x squared dx means the antiderivative of 3x squared with respect to x. That is x cubed plus a constant. What that tells me is that if I took the derivative of this, question? I don't know how long I haven't been recording. I hope it hadn't been very long. What I'm going to do is I'm going to do x cubed over x, which is plus 2x over x minus 4 over x. But I'm going to rewrite 4 over x like this. Do you see how that worked? Now let's take the antiderivative. What's the antiderivative of x squared? 1/3 x cubed. Good. What's the antiderivative of 2? 2x. Good. What's the antiderivative of negative 4x to the negative 1? Minus 4x to the 0.
Divide the 4 by 0. So, unlike
No, you don't have to do L'Hopital. Okay, what if I give you this? What's 1 over x the derivative of? What's 1 over x? What? Natural log of x. When you have an x to the negative 1, natural log. This was 4 over x, right? So, think it like this. Think it as 4 times 1 over x. So, 4 natural log x. Question, could I have said the natural log of 4x? Would that have been the same thing?
yes. No.
I'm asking you, what's the derivative of this?
1 over 4x.
Yeah, that's 1 over 4x times the derivative of 4x. Right? So that's a no. Always take the derivative, make sure that you get the step before. Okay? All right, let's go down to the next one. What do you think? Factor it out?
Multiply it out and then
Yeah, let's multiply it out. So this is the integral of did I do that right? Now take the integral or the antiderivative. Two-thirds x cubed x squared's part of it. 1/2 x squared minus 6x plus a constant. I'm sorry? If we didn't, I intended to. Questions so far? Okay, last one here. What do you think? Let's rewrite this as not a fraction. 2x to the negative 1/2 dx. This may take you a minute to think about. X to the half. What do I divide that by?
by 1/2.
2 divided by a half is,
So we add, yeah.
is it 1 or is it 4?
It's 4. Because that'd be 2 times 2.
Because if you take the derivative of this, a half of 4 is 2x to the negative 1/2. This will take you some practice, but you will get really, really fast at it. Okay, now this answers Tate's question. Are we just going to do polynomials? Nope. If I can take the derivative of sine and cosine, then I ought to be able to take their antiderivative. All right. Oh, but we do, because you all love trig. Okay, so the derivative of sine x with respect to x is cosine x. The derivative of cosine x with respect to x is negative sine x. So, what is the antiderivative of cosine x dx? Because is the derivative of sine x equal to cosine x?
Yes.
What did you forget? Plus c. Is it cosine x or negative cosine x? Negative cosine x. What's the derivative of cosine x? Negative sine x. With this negative will be positive, so there's my positive sine x. Good. All right, let's run them. Top left. I'm writing down what I'm hearing and then we'll talk. Is that 2 with the sine x and the cosine x or just with the sine x? Because this is a single polynomial. And besides, if I put one with each of them, a constant plus a constant is just another constant. So that one constant takes care of it. Doesn't matter. Derivative of cosine is minus sine. So derivative of this is 2 sine x. Derivative of this is cosine x. And derivative of that is 0. How about this one? Go ahead. No, no. The argument for sine, that's just x. And for cosine, that's just x. And that's going to stay that way. What do you think about this one? One-third t cubed? Why do you say plus cosine? Because the derivative of cosine t is minus sine t, which is what's sitting right here. No, because this equals this. So no, we're not putting that integral symbol. I hear some of you working on the next one. What are you getting? So is that minus correct? Yeah, it's right. It's right. Yeah. You'll forget it exactly one time on a quiz. I'll count it wrong, and then you'll never forget it again. What about that lower right corner there? Integral of square root x plus sine x dx. Where the crap are you getting a 2/3? Because I'm going to rewrite this sucker as x to the 1/2 plus sine x dx. So it's going to be x to the 3/2, but dividing by 3/2 is the same as multiplying by 2/3. What's the rest of it? Minus cosine. You sure it's minus? Yeah. Good. Questions so far? Okay. Now let's take a look at this. My hands are cold. Yeah. Use the given information about f prime and f double prime to find f. So we are told that f double prime of x is 2. We are told that f prime of 2 is 5, and we are told that f of 2 is 10. Now let me just show you how to work through one of these. If I integrate f double prime, don't write this down. What do I get? I get f prime, right? So let's write this down. F prime of x will be the integral of, what is f double prime? Of 2 dx. Well, what is the integral of 2 dx? 2x plus c. That's it. Plug in what we know about f prime so we can figure out what c is. Well, what do I know about f prime? That. So f prime of 2 is going to be 2 times 2 plus c. But what do I know that has to equal? That's got to equal 5. So c is 1. What then is f prime of x? 2x plus 1. Are you with me so far? So now I know what f prime of x is. How do I find f of x? Well, what do? I take the antiderivative or the integral. So what I know then, f of x, and you need to put your notation. You put f of x equals the integral of 2x plus 1 dx. Now I'm going to really watch. I'm going to make sure you make your notation right. What's this going to give us? X squared plus x plus c. Good. No, c was 1 here. C might not be 1 next time. Look what I know this time. I know f of 2 is 10. So f of 2 is going to be 2 squared plus 2 plus c. What's that, 6 plus c? But what does that have to be? Yeah, well, 10, yeah. So c is 4. So what is f of x? F of x is x squared plus x plus 4. And that's how you work backwards. Good. All right, so I think we've got one more on that page, is that correct? F double prime of x is x to the negative 3 halves. F prime of 4 is 2, and f of 0 is 0. How do I go about finding f prime of x? The integral of the second derivative. What is that? X to the negative 1 half. And what's your coefficient? Negative 2. I know that, correct? So f prime of 4. Now listen, I'm going to redo this. Are you okay if I do that? That's got to equal 2. Negative 1 plus c is 2. So c is 3. Tell me if I start going too fast. I'm not known for going too fast, but now and then I might. I don't talk fast enough. I'm going to erase this. So f prime of x is negative 2x to the negative 1/2 plus 3. How do I find f of x? Good. It's the integral of negative 2x to the negative 1/2 plus 3 dx. Now this is a case, Mason. You see how we're putting parentheses around the polynomial because it's a two-term polynomial. All right, go. Raise the exponent by 1. So negative 1/2 plus 1 is a half. And then divide this by that new exponent. That's f of x. We know c is 0 because f of 0 is 0. So what is f of x? Did I lose you somewhere? Okay. Correct. Correct.
True for all of them, like,
Only if f of 0 is 0. That's the only time you won't have a constant.
so if we have that, like, if it's true for 0, can we just skip all that and just think about that? Oh, wait, we don't know how to get that. Okay.
Yeah, no, you're going to write the steps I've got. Is this the last page?
Yes.
Now, if you go to the University of Arkansas and you are going to be an engineering major, you will take what's called the calculus sequence. Cal 1, which you're in now. Cal 2, Cal 3, Diff E. Diff E is differential equations. Differential equations. That's the course where I had Dr. Kimura, and he's the one who gave 0s, 1s, or 2s for homework grades. And I went to him and I said, can you explain to me how you grade homework? And he said, and I quote, and I use the same arm movements, oh, not worry, not worry. I worried. I made an A, but I worried.
What did he do?
He said, oh, not worry. So, an evergreen nursery usually sells a certain shrub after 6 years of growth and shaping. The growth rate during those 6 years is approximated by the differential equation dHdt equals 1.5t plus 5. A differential equation just means this is the derivative of some function. That's the derivative. It's like h prime. I don't know why I got so hung up about it. I don't think he ever told me that, but maybe he did. I don't remember. All I remember is not worry. Okay. So, honest to goodness, look, it scarred me. It's been how many years? I graduated from college in 1986. Scarred. But not worry. But not worry. Where T is the time in years and H is the height in centimeters. The seedlings are 12 centimeters tall when planted at time 0. Now, the first thing I want you to do, if I can get a highlighter, is I want you to mark that. You've seen some stuff like that as we have done those free response problems on stuff that I've told you that's not important because you don't know how to deal with that yet. Well, you're going to start learning how to deal with it. Now, it will help you to find your plus C. It can be. If you're dealing with position and stuff, it does have to do with where it is in relationship to the origin. So what I want you to do right now I want you to keep in mind that these points are t, h, right? Because it's time, height, correct? So what point does that highlighted information give us? Please write that down, 0, 12. Find the value of the differential equation above when t is 3. So we're going to actually take the integral. When I take the integral or the antiderivative of dh dt, what do I get?
H.
I get h with respect to t. So what I get is h of, I don't think I need a capital, do I? What I get is h of t. And that's the integral of 1.5t plus 5 dt. All right. What do you get? 3t squared? 3t, I don't think 3t squared works, does it? That gives you 6t.
Would it be 3/4? 3/4.
That'll be t to the second,
3/4.
1.5 divided by 2. Yeah, listen, if you take this and multiply top and bottom by 10,
Or that's 3/2.
that's 3/4.
No, I know, but like the tops. Yeah.
Yeah, 3/2 divided by 2. Yeah. Plus 5t plus c. But I know what h of 0 is. H of 0 is 12. H of 0 is c, so c is 12. So my h of t is 3/4 t squared plus 5t plus 12. Now we're going to evaluate that at t equals 3. Wait a minute. Wait. I did something wrong. This right here is the answer to part B. Look what part B is asking. Find the equation for h of t. That's part B. I messed up. You see I messed up? Well, just don't have a stupid teacher. Find the value of differential equation.
So erase everything?
It said to evaluate the differential equation when t was 3. I want to evaluate that derivative when t is 3. Yeah, your teacher was just stupid there for a minute and wasn't paying attention. Make some arrows. Yeah, draw some arrows. See, it didn't say find the value of the derivative. I wasn't paying attention. Find the value of the differential equation means find the value of the derivative when t is 3. Dummy. All right. So 1.5. See, I make mistakes, just like you said that thing was 0. See? So we just join the club and we'll just make mistakes together and we'll laugh about it and go on, right? Okay, so what's that give us? 4.5 plus 5? Now, using correct units of measure, this is a derivative, so it is a rate. So it is a rate. What does this mean in the context of the problem? The tree is growing. The shrub, is it a shrub or tree? Shrub. The shrub is growing at a rate of 9.5 centimeters per year at year or 3 years after planting. 3 years after planting. I'll post the notes so you can get it from the notes if you need to. Look at the next question. Find the equation for h of t. We did that, right? Just not at the right time. What did we get? 3/4 t squared plus 5t plus 12. How tall are the shrubs when they are sold? When are they sold? 6 years. So what do? Now, do I evaluate the height, or do I evaluate h of t, or do I evaluate the derivative? Because h of t is the height, because that was the growth rate. So listen, don't worry about taking the time to do that. You're going to do h of 6, right? And what's your unit going to be? So the shrubs will be that many centimeters tall when they are sold. Okay? You're going to have to do this. 2 o'clock. 2 minutes. A particle moves along the x-axis at this velocity. Notice time is positive. At t equal 1, the position is 4. Now, yeah, p of 1 is 4. P of 1 is 4. What is the acceleration of the particle when t is 9? We're going to talk through this. We don't have time to work it. I've got an equation for velocity. I want to know acceleration at a moment in time. You take the derivative. Pay attention. Don't take an integral when you're supposed to take a derivative. Look at part B. What is the position when t is 9? Because you know the velocity, you need the position, so you'll take an integral. Okay?